Hello, welcome back once again. Today we have this interesting Olympiad math problem. We have 3 raised to the power of x is equal to x to the power of 9. Our goal is to solve for the x values. Okay, so how can we solve this problem? Now let's get started. From the left hand side here we have 3 raised to the power of x. So this is equal to, from the right hand side we have x raised to the power of 9. Okay, so what are we going to do next? Now let us raise both sides to the reciprocal of to the reciprocal of 9 times x, right? So the reciprocal of 9 times x means 9 times x to the power of -1. That will give us 1 over 9 times x. So you may ask, where is 9 times x coming from? We see that from the right hand side the power is 9, and from the left hand side the power is x. So that is why 9 times x is involved here. Okay, so we're going to raise both sides of the equation to the power of 1 over 9 times x. So when you do so, the left hand side will be 3 raised to the power of x into bracket raised to the power of 1 over 9 times x. So this will be equal to, from the right hand side, x to the power of 9 raised to the power of 1 over 9 times x. Okay, now we know this property that whenever we have a to the power of b in bracket to the power of c, that the powers will multiply together, right? So that is a raised to the power of b times c. And when you multiply these powers together from here, you will observe that this x will cancel this x, and from the right hand side this 9 will cancel this 9. Therefore we have now 3 raised to the power of 1 over 9 is equal to x raised to the power of 1 over x from here. Okay, so now from the right hand side we have x raised to the power of 1 over x is equal to, from the left hand side we have 3. Now 1 over 9 is same as 3 divided by 27, right? And this is same as 3 raised to the power of 3 multiplied by 1 over 27. Okay, with the above property I mentioned earlier, that a raised to the power of b times c is same as a raised to the power of b in bracket raised to the power of c. So that right hand side now we can write it as 3 raised to the power of 3, then raised to the power of 1 over 27. So this will be equal to 3 to the power of 3 is 27, then raised to the power of 1 over 27. Now compare this left hand side and the right hand side. You will see that x is equal to 27 is an obvious solution from here, right? So this is an integer solution, but we still have another real solution. So let's go ahead and figure it out. Okay, so now from here we have x raised to the power of 1 over x. So this is equal to 3 raised to the power of 1 over 9. Now let us ln both sides of this equation. So we have the natural log of x raised to the power of 1 over x. This will be equal to the natural log of 3 raised to the power of 1 over 9. With this property of natural logarithm, the natural log of a to the power of b is equal to b multiplied by the natural log of a. So this one here, this power come down here, right? And this power come down here. So this will become 1 over x times the natural log of x. This will be equal to 1 over 9 times the natural log of 3. So 1 over x is same as x raised to the power of -1, right? So this is x raised to the power of -1 multiplied by the natural log of x. This will be equal to 1 over 9 times natural log of 3. Now for this part here, let us use this idea. We know that a raised to the power of b is equal to e raised to the power of b multiplied by the ln of a. So this part here will become e raised to the power of -1 times natural log of x, which is same as negative natural log of x. Then we have multiplied by the natural log of x. So this is equal to 1 over 9 times the natural log of 3. Now, our idea here is to make sure that this power of e is equal with this expression here. So how exactly can we achieve that? So we can achieve that by multiplying both sides by -1, right? So multiply both sides by -1. So we get here this -1 multiplied by the natural log of x. That will give us the negative natural log of x. Then times e raised to the power of negative natural log of x. So this is equal to -1 over 9 times natural log of 3. Now we can see that the power of e is equal with this expression here. So we can use the Lambert W function, but let us take note of the following property of the Lambert W function, right? So the Lambert W function of k times e raised to the power of k is equal to k. You can see the power of k is equal with this expression here. So now we can take the Lambert W function on both sides. Okay, so by so doing, we can see that this left hand side we evaluate nicely, right? So the left hand side will give us negative natural log of x. So this is equal to the w of -1 over 9 times the natural log of 3. Now from here, multiply both sides by -1, we get negative natural log of x. Natural log of x will be equal to negative w of -1 over 9 times the natural log of 3, right? Now we can make a common base of e from both sides, right? So this ln cancel the e, so leaving us with x is equal to e raised to the power of negative w of -1 over 9 times the natural log of 3, right? So this here is approximately equal to 1.1508248213, and this is the correct answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share.